Okay, so in this class we'll discuss these two questions here. First one we'll discuss 30. Okay, is the velocity time graph for a car uniform or constant velocity? In other words, the car is in zero or no acceleration, right? So here, so let us draw the graph of that car. Velocity time graph means this one. So we have here the y-axis, and the horizontal line we know is the x-axis. So you also likewise draw, write this, pause the video and write this question and draw this along with me. This is the origin, and on the x-axis, let us say we took time. So here on the x-axis, so we're taking time in hour. 1 hour, 2 hour, 3 hour, 4, 5 hour, etc. Then on the y-axis, we take the velocity, let us say 10 km per hour, 20, 30, 40, 50, etc. So on the y-axis, we plot the velocity in kilometer per hour, let us say. So such kind of a graph in which we plot we take the time on the x-axis and the velocity on the y-axis is called velocity time graph. Now we're drawing for a car in uniform motion at 40 km per hour. So this is the 40 km per hour. So after 1 hour also it's still at 40 km per hour. After 2 hours also still at 40 km. After 3 hours also still at 40 km. So throughout the journey, let us say 4 hours journey, the car has not changed its velocity. It is traveling with the same velocity. So this is called uniform or constant velocity. Constant means unchanging velocity. So when a car is moving with same velocity 40 km per hour throughout the journey for 4 hours, 5 hours total journey, it did not even change slight, even above 40 or below 40. That's called uniform velocity. And when the car is in uniform velocity, we know there is no acceleration. For acceleration, it is acceleration, the velocity must change, must increase above 40 or below, go below 40, 39, 38. But that is not happening. It's exactly going with the same velocity. So this car has no acceleration. That's why we have here zero or no acceleration. So for that kind of a car moving with uniform velocity, if you join the dots, you will get like this, a graph, which is a straight line, okay? Which is a straight line parallel to the x-axis. So we will write, so the velocity time graph of a car or any moving object of a car in uniform velocity, uniform or constant velocity, meaning is same, in uniform velocity is a straight line. It's a straight line, as we can see just now, parallel to the x-axis, and the x-axis is, in other words, the time axis, the axis on which we took the time, okay, time of the journey. Now it does not change, means the graph is this line here, line parallel to x-axis, this line, this graph, it does not change, okay, it does not change. Okay, its height does not change. Okay, so you just, hence, since it is a straight line parallel to x-axis, we can say hence its height, means the height of the graph, its height does not change, means remains same, does not change with time. So here you see it's always at 40, 40, 40. It is not going above 40, means the graph will be here, sometimes below here, but below 40, but because it's a uniform velocity, its height does not increase or decrease with time, right? After 1 hour also at 40 km/h height, 2 hours also, 3 hours also, all throughout, since it's a straight line, it does not change height with time. Okay, so then one use of this velocity time graph of uniform motion is we can velocity time graph is we can find the speed of the car. Okay, so for that you may want to take here 2 points. Let us say here T1, and here let us say T2. So let us say that is the point C and D. C and D. So from this point, if you want to, how will you get the distance traveled by this car? So from that point on the time axis that you have taken T1 point, which is C, and T2 point, which is D, you draw a line perpendicular to the graph here, perpendicular to the graph, and let's say it meets the graph at A and B respectively. We'll have to do like that, the steps to find the distance traveled by the car between T1 and T2, between T1 and T2. So before we go and find that, so this here, the velocity time graph here that we have drawn is that of a car with uniform velocity of 40 km/h. I mean, this graph is the graph of a car moving with all the time 40 km/h. Okay, so now next we're going to find the distance traveled. So we can write here to get the distance traveled, okay, distance traveled by the car between T1, which is point C, and T2, which is D here, T2, which is D, to get the distance traveled by this car between T1 point and T2 point using velocity time graph. Using velocity time graph, draw perpendiculars from these points, means these 2 points C and D, from these points on the graph line at A and B respectively. So that is the first step we do when we want to find the distance traveled by the car between 2 time points T1 and T2. From the same point you draw a perpendicular, the 2 perpendiculars on the graph. The graph is this line. Okay, then here, once you do that, here, now we know that to find speed is distance by time, right? So to find the distance, here this distance, it is speed into time or velocity into time. So we need velocity, speed or velocity into time. Velocity and time. So here, HC or BD represents the velocity of 40 km/h. So we know the velocity is constant, so we have the velocity. So to get the distance here, we need time. And you write here, this one here, CD, which is nothing but this taken points between T1 and T2, C and D. This CD is the time, okay, that we need for the formula to calculate. So CD is nothing but T2 minus T1 is the time, is equal to the time, right? So this is, we have now the velocity, which is 40 km per hour, and the time, which is CD or T2 minus T1. So we can write down, therefore, distance covered by this car or displacement will be equal to formula here, velocity into time. So we write here velocity into time. We know this formula, velocity or speed into time. Here we are taking velocity. Now velocity is nothing but here this one, say 40, which is SC. So you can write here SC, or you can write BD also. Into time is CD. You can see here CD. So SC into CD is what? SC length into CD, length into breadth. This ABDC is a rectangle, so length into breadth. So it's the area of this rectangle. Keep that in mind. So there is SC is here 40 km per hour. This hour minus 1 come down, then plus 1 into CD is T2 minus T1. So we write here T2 minus T1. Right? And then as we continue, we will get here that will be equal to 40 km per hour into T2, as you can see here, from 0 to T2 here is nothing but 4 hours. So we write there T2 is 4 hours. 4 hour minus T1 to here. So 0 to 1 means 1 hour. So we write here 1 hour. So we get here 40 km per hour into 4 minus 1 is 3 hours. So this is 3 4s are 12. So 1 0. So the car has traveled 120 km between T1 and T2, meaning for a time period of 3 hours. In 3 hours, it is covering 120 km per hour. So we can find out the distance traveled by this method. That is, take the 2 time points that you want, draw perpendiculars on the graph, and the area of that rectangle, length into breadth, will give you the distance traveled. That's what we're trying to learn today. Okay. So in effect, last paragraph. So just now, hence, you can write your hence from this calculation we did just now. That means hence, okay. Hence the area enclosed, the okay, the distance or displacement, okay, distance covered by this car or moving object covered is always given by the area, okay, by area enclosed by the velocity time graph, the area under or enclosed by velocity time graph. This one here, this is the velocity time graph, and the time axis and the time axis. See here, since we are getting here AC into CD means length into breadth, area of this rectangle, which is enclosed between the graph and the time axis of the 2 points here. So this today we learned that when a car is in uniform motion, the distance traveled by the car will be given by the area enclosed between the velocity time graph and the time axis, given by the area enclosed by the velocity time graph and the time axis. So hence the distance covered by this car is given by the area enclosed by the velocity time graph, this one, and the time axis, this one. See here, this area, because we can see here AC into CD means area of the rectangle, which is the figure enclosed between velocity time graph and the time axis for the time period T1 and T2. So that is what we learned. Okay, so the next question, 29. So what this we have already understood, so we'll just write the definition for this. Question number 29 is, on to know this, what is velocity time graph? That's what the question is asking us. We have understood, so just write the definition directly. Okay. For an object moving in a straight line, for any object like a car moving in a straight line motion, straight line, okay, if the time is represented if time is represented along the x-axis and its velocity along the y-axis, okay, y-axis, such a graph is called, such a graph, right along with me, is called, such a graph is called velocity time graph. Okay, so that's your answer for what is velocity time graph. Okay, so that concludes this class. We'll continue with the velocity time graph for uniform acceleration. This is velocity time graph for uniform velocity or no acceleration. But in the next class, we'll see velocity time graph for uniform acceleration. Okay, uniform acceleration.